Hello everyone, and welcome to the fourth lecture of the pulse measurements using Anritsu vector star and pulse modulator test set. So in the last video, actually we studied the second most important measurements for a pulse DUT. Till now, for the entire series of videos, we have covered why the pulsed S parameters or the pulse measurements are so important. We have studied a lot about radars and the effect of the pulse width, the PRIs, the PRFs, and a lot of fundamentals of what are the various methods of measuring pulses. We have seen the effect of increasing and decreasing the pulse width on the spectrum, and we have seen that doing a direct acquisition of entire energy content of a particular pulse is the basic or the most advantageous way of doing the measurements. And Anritsu does have a 200 megahertz wide IF bandwidth through which we can actually capture the entire spectral content of a pulse, and we have the resolution of 2.5 nanoseconds, which is again industry leading spec in the world today. Moving on, last time, as I told you in the beginning, we had done a point in pulse measurement. Till now we have done a pulse profiling, which is basically analyzing the pulse for its various parameters, the pulse width, the overshoots, ringing, characterizing a pulse. The point in pulse is basically when a customer wants to characterize a DUT or make the pulse S parameter measurements, and we actually saw how a flat portion of the pulse is actually seen for various frequency sweeps, and how the power actually varies, and which portion of the pulse is basically the best point to analyze. The third measurement, which is the most important and again most done measurement, is the pulse to pulse measurement, which we have seen as a coverage of the basic pulse measurements. So in pulse to pulse, what happens is we select a particular portion of a pulse, and then we see the variation that actually happens for the same region of that pulse, from one pulse to the other to the other. So that means we are analyzing a particular portion of the pulse on a number of pulses being analyzed. Why is this important? Because sometimes the DUTs might misbehave every time they encounter a new pulse. So it's very important to make some measurements on the pulse to pulse setup as well. So coming back to the pulse view configuration, as you can see here, last time we did the pulse profiling, then we did the point in pulse, and today we will do a pulse to pulse measurement. Again, before we do that, we need to first see and select a portion of the pulse that we want to analyze. So let's go back to pulse profiling and first select a particular place or a point in pulse that we want to analyze. So the measurement width, I will go back to 2.5 nanoseconds because we want to analyze it to the fullest. I'll do a 0 nanoseconds as the start time, 400 nanoseconds as my stop time, which gives me a non-overlapping window of 161 with 161 points. And let's see how our pulse actually looks like. So you can see that our pulse, let me do a scaling, I'll do an auto scaling, and the frequency, let me go back to 10 gigahertz because we were analyzing it at 10 gigahertz. So once I have the pulse back in my hand, now I want to see this selected portion. Let me again choose the markers. We can choose the marker 1 and or maybe this time marker 2, because we were using marker 1 for the other setup. Let's switch off marker number 1, and now let's select marker number 2, and again I actually want to choose an area from say 160 nanoseconds to say 220 nanoseconds. Okay, so now I want to know what happens or what is the variation in this portion of a pulse from from pulse number 1 to 2 to 3 to 4, like that. Now since I've selected my portion of interest, I'll go back to pulse view configuration, and this time I do a pulse to pulse measurement. And again it's very simple and straightforward measurement setup that you want to do. So the measurement width right now is 5 nanosecond. I don't want to do that. I want 100, or because we chose 160 and 220, so let me do a 60 nanosecond sort of pulse width. And then the delay, because we started at roughly around 160, so a good portion is basically covered. I can do 100 as well because the pulse was pretty stable there. So I do 100 nanosecond. Again, I'm just analyzing. If you see the pink portion, which is the B2 profile, and the green portion of the actual pulse speed that we want to analyze, so we have actually covered the main area of the pulse that we want to analyze. So once I have done these settings, all I need to do is click done, and what you should be able to see is basically a good straight flat line. And what is happening here is oh, I'm sorry, I forgot to show you one more thing. The number of pulses that I've chosen here is 161, and I've not done an averaging. Actually, this is very important, and I'm sorry that I forgot. But the number of pulses, that say suppose I want to analyze this portion, or that particular portion of the pulse I want to analyze over 10 number of pulses. So I put a 10, and when I am done with the number of pulses, now that particular section is going to be analyzed over 10 pulses coming to the dot and coming out to the receiver. So you can see it's pretty stable. It's not that bad. I can actually do an averaging on, so that I have a pretty stable trace. So now you can see that for each and every pulse I have a pulse power or a pulse profile of roughly around -38 dB of power is available. So this is how basically pulse to pulse variation is done. Now this might not be you know, seeing very visual to you, but basically what is happening here is, and let me just quickly do some setup for you so that I can explain you in a little bit of depth here. Let me go back to pulse view, and let me choose a PRI of say I choose a PRI of 10 microseconds, okay, because I want to show you that how many pulses we can have and what basically we are measuring. So I have a 10 microsecond of pulse, and then let me do let me go to PG4 and create a burst for you guys. So the number of bursts that I want is 9, because my PRI is 10 microseconds. I do a 9, and a period I do to say 1 microsecond, and delay is 0, and the width I can actually do to 2.5 or maybe 200 nanoseconds. Yeah, 200 nanoseconds. So I do that. Now you can see that I have 9 pulses with me, right? And what I want to do is I go to the measurement menu and I select in the pulse profile, just to show you. In the pulse profile I put a start of 0 microseconds and a stop of say 9.5 microseconds, and because there are so many points, I have the calculation already done for 3801 number of data points, and the resolution is 2.5 nanoseconds. Right, so I have a start of 0, measurement stop is 9.5 microseconds. So I have covered this portion, and I do we're done. Let's see what happens. Now this is gonna take some time, and the reason for that is because now there are so many pulses, and we are actually analyzing them with a fine resolution of 2.5 nanoseconds. So what you should be able to see in a while is actually 9 pulses of yeah, there you go, in front of you. And with the point or a pulse to pulse measurement, what I was trying to show you is the fact that if you see the marker here, I've selected say at 205 nanoseconds. You know, if you remember, our starting point for that pulse was 160 nanosecond, and the stop was for 220 nanoseconds. So what I basically want to see is the response, which here is, again, you can see it's minus 37, somewhere around that, at 190 nanoseconds, right? If I move this marker to the second pulse and say suppose again at the same time, you would see that the power is again roughly around minus 37. So what basically what you are seeing here is the fact that how many pulses, but what a pulse to pulse measurement basically does is it does a measurement of a basic point from various pulse to pulse. So this is how a basic measurement from the standpoint of pulse to pulse is basically made. Now these are only 9 pulses, but you can actually have say 90 burst videos or bursty signals, and the fact that Anritsu can do this is because, again, we have a record length of 500 milliseconds, which is basically 0.5 seconds, and it will be with full resolution, and we are basically 10 times better than our closest competitors. So with that, basically we come to a conclusion of our pulse view configuration. As I told you, the continuous point in pulse and continuous profile are basically for capturing the transient responses of a particular dot. If you have more interest in knowing these continuous point and pulse and continuous profile, please let us know. As far as the power is concerned, this basically is a menu which actually allows you to do a power calibration for the pulse measurement. Now the fact that you see that you have a start and a stop power cal gates is the fact that as I told you, most of the customers would want to do the S parameter measurements in basically the flat portion of the pulse. In fact, some people want to do it in the flat portion, but some people would want to do at the rising edge of the pulse as well. So it basically depends, but you have to basically choose a particular portion of the pulse. You may very well choose it to be the entire pulse, but normally what I have seen in my experience is that they would actually choose a flat portion of the pulse. So for selecting that portion of the pulse, you have a start and stop, and then you can either do the calibration in the pulsed mode using a pulse power sensor and a power meter, which again is available from Anritsu, or you could do an average pulse power measurement using an average or a CW power sensor as well. So this menu basically lets you do a power calibration. Sometimes what happens is that customers also ask me the fact that, hey, can I apply an amplifier in your pulse modulator test set? So the answer to that question is yes. As you can see in this image, we have dedicated ports for the high band, which is above 2.4 gigahertz VNA, and then for the lower band also we do have an LB amplifier port 1 as well. So the customer can actually do a pulse an amplifier insertion at those places. In fact, for that matter, if the power requirement is not that much, but still an external power amplifier is required, you can also put that in the port 1 source going to the modulator as well. So all the combinations for making various pulse measurements are available. As I told you, our pulse menu with 4 pulse generators, as you can see here, PG1, PG2, PG3 and PG4. You can use various of these pulse generators to maybe pulse the RF or to pulse the bias, or you can actually do an pulsed IV as well. Again, we are making use of PG4 to actually act as a pulsing RF structure for the pulse demonstration module. I hope and believe that these measurements were useful for you. And we will be back with another short video session next time on making noise figure measurements, and we will also be making some amplifier measurements as well. Thank you again for tuning in here, and see you next time. Thank you.